Hello, friends. Today we're continuing our learning about logarithms, and today we're going to be looking at logarithmic arithmetic properties. So when we have something happening in a logarithm, the way that we can split it up or combine it or simplify, it's going to allow us to be able to solve problems. And this does show up, for example, in my AP Physics C class. This shows up. We have to do some of these, use some of these properties, and it has other applications as well. But we are learning precalculus, that's why we're here, and this is one of the topics. So it's pretty interesting. I think it's pretty cool. So we're going to start with the product property. When we have something like this, log base b of x times y, so log base b of a product, we can split it up. This actually becomes log base b of x plus log base b of y. Now, I kind of wrote out an explanation. Maybe this will help you understand. If it works for you, great. If not, you can skip this. But here's kind of the explanation. Look, if we have log base b of x times y, what does that mean, right? So remember, think of this in terms of the exponential version of this. That means b to some power is xy. So I'm going to label b. So b to the p power equals xy. I'm saying log base b of xy is p. Okay. Now, I want to come up with a different expression. B to the q power equals x. You'll see why I'm doing this in a minute. Okay, so log base b of x is q. Sorry, so q is the exponent of b that gives me x. And then log base b of y equals r, right? So b to the r power is y. So again, the exponential version of the original function is b to the p power equals xy. Well, x can be written as b to the q, and y can be written as b to the r. So x becomes b to the q, y becomes b to the r. Now, b to the q times b to the r, that's just b to the q plus r. And now look what I have. B to the p equals b to the q plus r. So that means that p equals q plus r, but p is my original logarithm, log base b of xy. Q is log base b of x, and y, or r, is log base b of y. And so here's a little proof for what we call the product rule of logarithms. You could construct a similar proof for the quotient property, right? Log base b of x over y is log base b of x minus log base b of y. So if you have a fraction there, you can separate it. It becomes subtraction. And then the power property, right? Log base b of x to the n equals n times log base b of x. And they give you some examples there you can look at. But let's apply this and see how this works. It says, so we're going to write the equivalent expression by condensing each of these. Okay, so log base 4 of x plus log base 4 of y. So this can be log base 4 of x times y. All right, this is like what we just looked at. Okay, very simple here. The division property. This becomes log base 3 of 5 divided by z. This one, it's we've got a few that are being a few things going on here. So let's simplify this a little bit. I'm going to show you something. So log base 10 of x minus, what's this? Log base 10 of 5 plus log base 10 of z. Okay, this becomes log base 10 of x minus, now I can multiply 5 and z, log base 10 of 5z. Now it's x minus, so I'm going to say log base 10 of x over 5 times z. Okay, that's nice. So now, again, here I'm going to use the product or the exponent rule, right? The power property. So log base 2 of x to the third minus log base 2 of y. So this becomes, now I use the division rule. Log base 2 of x cubed over y. E. I'm going to rearrange this and bring the log base 7 of 4 in front. I can't group together the 5 log 7b plus log 7 of 4 like I did before because it's not the subtraction thing. Those things can't be grouped together. So this is log base 7 of a. I'm going to take care of the power rule plus log base 7 of 4 minus log base 7 of b to the fifth. Take care of that power rule as well. And so now I'm adding the two things first and then subtracting the last thing. So the a squared and 4 are going to go on top, and the b to the fifth is going to go on the bottom. I get log base 7 of a squared, 4a squared, over b to the fifth. Okay. And then now, well, what does this look like? What do I do with this? Well, well, I have a base of 6. So think of it this way. 6 uh, squared would give me what? Because remember, the way that logs work is that it's log base 6 to what power will give me the thing that's in the logarithm. So this is actually log base 6 of 36. Because again, so 6 to what power gives me 36? 2. So 2 is actually the solution of this. 2 and log base 6 of 36 is the same thing. So plus log base 6 of x, same base. So now I can combine these. So this is log base 6 of 36x. Okay, example 2. Which of these is equivalent to log base 3 of x squared over y? And now I can separate this now. So first I get log base 3 of x squared minus log base 3 of y. And I have the power rule, right? So 2 log base 3 of x minus log base 3 of y. And that is option C. Okay, so those are the basic rules there, right? The product rule, the division rule, and the power rule. Example 3, what we're looking at here. So we have a function, and this function is a horizontal dilation of g of x, right? Show that f can also be written as a vertical translation of g, where it's, g of x plus some constant. Now, here's the thing. We know that by the way when we do transformations, that anything that happens inside of the function happens horizontally, and it does the opposite. So log base 6 of x is like so it looks like I'm multiplying by 6. So, normally I would think that I'm expanding, but it does the opposite. So I'm actually taking it and I'm shrinking it down by a factor of 6, from 0 point, right? But that would also be the same thing because of the shape of the graph. That would also be the same thing as just raising it. So it's like taking log of 6 or log of x, right? By the way, naturally log base 10 if we don't write it. So log of x and then adding some constant, which would be log base 10 of 6. So just by using the product rule, this becomes log base 6 plus log of x. And log of 6 is some constant, so this is k, and g of x would be just the log of x. Okay, let's see what this looks like in Desmos. Okay, so here I've got log of x. Now log of 5x, so it's not 6x, but it's the same, similar. So log of 5x would be 2. Now there's a question, right? Am I just taking the whole thing and shrinking it down, like bringing closer to 0? Or am I just raising it by a certain factor? Notice it's the same thing either way. By doing the horizontal dilation, right, or the shrinking, or by raising the whole thing vertically, it's the same thing, which is what we just showed, and also what we see now in the graph. Here's the change of base property, and this was the trick that I showed you in some calculators for changing the base. It's hard to change the base sometimes. It's a little tricky. So instead of changing the base, you can just take log base anything of something and put it over log base that same thing over whatever you want the base to be. Right. And so what this shows us is like we just said, all logarithmics they're just vertical dilations of each other. So it's like taking the original function, and then based on what you put it over, right, so you're taking the function and dividing by something. So what you're doing is you're just shifting it vertically. You're expanding it or shrinking it vertically. And so, yeah. Okay, example 4. F of x is log base 4 of x, and g of x is log base 9 of x. Show that f is a vertical dilation of g by finding the value of k such that f of x equals k times g of x. Okay, so we've got log base 4 of x and log base 9 of x. So I want to change the base, right? So this is going to be log base 4 of x equals log base 9 of x over log base 9 of 4, right? And log base 9 of 4 is a constant. It's not a variable. It's not changing. So 1 over log base 9 of 4 times log base 9 of x. And this is equal to k. And then this is equal to g of x, a different function. And then we've seen this before, but the natural logarithm function, which we call ln, right, or natural log when you read it, but ln of x or natural log of x is just log base e of x. And all the same rules apply. So this example is just to show you that the product, division, power rule, they all apply in this case, because I can take this and this becomes natural log of x to the third minus natural log of y to the fourth. And this is equal to natural log of x to the third over y to the fourth. And that ends up being a. Okay. So there you go. Power rule, division rule, and product rule for logarithms always come in handy. Thanks for watching. Don't forget to like and subscribe.